March 17, 1943. North Atlantic, approximately 400 nautical miles southwest of Iceland. Oberleutnant Werner Hartenstein gripped the periscope handles aboard U-156, watching the destroyer's silhouette slice through the grey dawn waters above him. His knuckles whitened as he pressed his eye against the rubber cushion. The British warship moved with practiced efficiency, her sonar pinging rhythmically through the cold Atlantic depths. Hartenstein had trained for this moment. Dive deep, use the thermal layers, wait for the blind period when the destroyer lost contact. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. His training had been explicit. German submarine doctrine emphasized that deep diving was the ultimate defensive maneuver. Below 200 meters, instructors at submarine school in Kiel had taught him a U-boat became effectively invisible. The ocean's pressure and temperature variations would scatter sonar waves. Surface ships would lose contact. The crew would then execute evasive turns, changing depth and heading, making pursuit impossible. Hartenstein had executed this maneuver successfully on 3 previous war patrols. This time would be different. At precisely 07:15 hours, U-156's hydrophone operator called out a new sound. Not the familiar whoosh of depth charges tumbling off the destroyer's stern. Something else. Something metallic. A rapid series of splashes. 24 distinct impacts on the water surface directly ahead of the destroyer. Before Hartenstein could process this information, his boat shuddered violently. The first explosion punched a hole through U-156's pressure hull at frame 37, just aft of the forward torpedo room. Water erupted into the submarine at 400 gallons per minute. The second explosion, arriving 3 seconds later, struck amidships. The pressure hull cracked like an eggshell. Hartenstein and 52 men died instantly as the Atlantic Ocean compressed their steel coffin into scrap metal. The British destroyer above them had used a new weapon. 24 mortar bombs, each containing 35 pounds of Torpex explosive, had been fired in a circular pattern 250 yards ahead of the ship, while sonar contact remained firm. The weapon was called Hedgehog, and it represented a fundamental transformation in anti-submarine warfare that would shatter every assumption German U-boat crews held about their survival. The mathematics of this transformation were already being written across the Atlantic in statistics that submarine commanders couldn't ignore. Between September 1939 and May 1943, British depth charge attacks had achieved 85.5 kills from 5,174 attacks, a success ratio of 60-1. The new forward-throwing weapons would achieve 47 kills from just 268 attacks, a ratio of 5.7-1. German submariners were about to learn that diving deep no longer meant disappearing. It meant becoming a stationary target for a weapon system that could reach through water itself and strike with precision they couldn't evade. The journey to this technological revolution had begun 2 years earlier in 1941 in the cramped workshops of the British Admiralty's Directorate of Miscellaneous Weapons Development. The organization, nicknamed the Wheezers and Dodgers for its collection of retired naval officers and civilian engineers, had been tasked with solving an impossible problem. How could convoy escorts attack submarines without losing sonar contact? The problem was fundamental to underwater warfare. Allied sonar, called ASDIC by the British, transmitted sound pulses through water at a frequency of 14 kHz. When these pulses struck a solid object, they reflected back as echoes. Operators could calculate range and bearing from the echo timing. It was revolutionary technology, but it had one critical flaw. As a destroyer approached a detected submarine, the time between transmitted pulse and returning echo grew shorter. At approximately 200 yards distance, the gap became so brief that human operators could no longer distinguish outgoing pulse from incoming echo. This phenomenon, called instantaneous echo, created a blind spot directly beneath and ahead of the attacking ship. In this zone, which extended roughly 300 yards in every direction, submarines became effectively invisible to sonar. Every German U-boat commander knew this. Training emphasized exploiting the blind period. When depth charges began falling, execute sharp course changes. Vary depth rapidly. Use the 15 minutes of turbulence from exploding charges to escape while sonar remained disrupted. The tactic worked. Throughout 1940 and 1941, German U-boats operated with devastating effectiveness. Lieutenant Günther Prien, Otto Kretschmer, and Joachim Schepke led their boats on patrol after patrol, sinking Allied shipping faster than British shipyards could replace losses. The first happy time, German submariners called it. Admiral Karl Dönitz watched with satisfaction as his wolf packs achieved what seemed like strategic victory in the Battle of the Atlantic. British imports of food and war materials fell to critically low levels by March 1943. Winston Churchill would later write that the only thing that really frightened him during the war was the U-boat peril. Britain's survival depended on solving the blind spot problem. The solution came from an unlikely source. Lieutenant Colonel Stuart Blacker, a retired British Army officer, had developed a weapon between the wars called a spigot mortar. The design was elegantly simple. Instead of placing explosives inside a barrel and firing them with propellant charges, Blacker's system used a fixed steel rod, the spigot, mounted on a base plate. The projectile had a hollow tail that fit over the spigot. Propellant charges fired against the spigot, launching the projectile skyward. The Blacker Bombard, as the infantry version was known, could fire various sized warheads from the same launcher. The principle worked for anti-tank warfare. Could it work against submarines? The Directorate of Miscellaneous Weapons Development adapted Blacker's design for naval use. Instead of a single mortar, they created a cradle holding 24 spigots, arranged in 4 rows of 6. Each spigot would fire a 7.2-inch diameter bomb weighing 65 pounds. The explosive charge was 35 pounds of Torpex, a mixture more powerful than standard TNT. The bombs would be fired ahead of the attacking ship, landing in an elliptical pattern approximately 140 feet long by 120 feet wide. Range was 250 yards. The firing sequence was staggered, so all bombs landed nearly simultaneously, minimizing stress on the launcher mounting and allowing easy retrofit to existing ships without deck reinforcement. The critical innovation was the contact fuse. Unlike depth charges, which exploded at preset depths regardless of proximity to the target, Hedgehog bombs only detonated on direct impact with a hard surface, a submarine's pressure hull, or the ocean floor. This feature solved multiple problems simultaneously. First, if the pattern missed, the ocean remained undisturbed. Sonar contact could be maintained. The attacking ship could immediately reload and fire again. Second, no explosion meant no result. Crews couldn't deceive themselves that near misses might have damaged their target. Third, a single explosion confirmed a direct hit, and direct hits were almost always lethal. The physics of underwater explosions explained why contact detonation was so devastating. Traditional depth charges exploded some distance from their target, perhaps 50 feet away. The explosive shock wave traveled through water, gradually dissipating as distance increased. Water between charge and target absorbed energy, cushioning the blow. A submarine might survive dozens, even hundreds of near misses. U-427 famously survived 678 depth charges dropped against it in April 1945. Hedgehog bombs eliminated this cushioning effect. 35 pounds of Torpex detonating directly against a pressure hull punched holes 3 to 4 inches in diameter. At depths between 200 and 300 feet, where U-boats typically ran when under attack, water pressure at the breach point was tremendous, approximately 130 pounds per square inch. Water entered the pressure hull at 400 gallons per minute through a single hole. 2 or 3 simultaneous hits meant instantaneous catastrophic flooding. The submarine's fate was sealed within seconds. Temperature inside the boat rose rapidly as flooding water compressed the air inside the hull. Within minutes, internal temperature climbed above 200 degrees Fahrenheit, searing the lungs of crew members still alive. The boat lost depth control almost immediately, settling deeper into the crushing pressure of the abyss. Increased depth meant increased flooding rate. The cycle accelerated until the pressure hull imploded with a sound like thunder, audible through water for miles. Death came quickly, but terror preceded it. The prototype Hedgehog launcher was tested aboard HMS Westcott in 1941. Initial results were disappointing. Success rates hovered around 5%, barely better than depth charges. Technical problems plagued the system. Heavy North Atlantic weather covered launchers with spray and seawater. Firing circuits shorted out, launching incomplete patterns. Crews, accustomed to the dramatic explosions of depth charge attacks, felt discouraged by Hedgehog's silent misses. A psychological problem emerged. Depth charge attacks, even unsuccessful ones, produced satisfying underwater explosions. Crews could believe they had damaged their target or at least frightened the enemy. Hedgehog's silence after a miss felt like failure. Many captains preferred the familiar spectacle of depth charging over the new system. The Royal Navy issued a directive in early 1943 ordering commanders to report why they had not used Hedgehog on underwater contacts. The results blamed crew inexperience and low confidence in the weapon. Everything changed when the Directorate of Miscellaneous Weapons Development sent an officer to the operational base at Londonderry, Northern Ireland, where Atlantic escort vessels were stationed. He conducted ship-wide talks about successful Hedgehog attacks. He explained the mathematics. He demonstrated proper firing procedures. He showed crews how to maximize hit probability through careful sonar tracking and precise timing. Within months, kill rates improved dramatically. By the end of the war, statistics showed that 1 in every 5 Hedgehog attacks resulted in a confirmed submarine kill. Compare this to fewer than 1 in 80 with conventional depth charges. The improvement was revolutionary. For German submariners, the first encounters with Hedgehog came without warning. They understood depth charges. The tactic was familiar. Dive deep, perhaps to 250 or 300 meters, the submarine's test depth. Execute evasive maneuvers during the blind period. Count the explosions. Wait for the turbulence to settle. Surface after dark and escape. Hedgehog changed everything. Lieutenant zur See Hans Müller, serving aboard U-645 during a patrol in April 1943, recorded in his war diary the moment his understanding of submarine warfare shattered. We detected the destroyer's ASDIC at 0900 hours. Standard. Procedure. Commander ordered dive to 280 meters. We turned to port, reduced speed to silent running. The crew took positions for depth charge attack. We waited for the familiar pattern of explosions. Instead, silence. Then 3 impacts in rapid succession. The boat shuddered as if struck by hammers. Forward compartment reported flooding. Pressure hull breached at frame 22. We surfaced immediately to abandon ship. Half the crew died in the water before rescue came. I learned later that the British had used a new weapon. We never heard it coming. Müller survived only because U-645 had been shallow enough to reach the surface before catastrophic flooding occurred. Most crews weren't so fortunate. The weapon's effectiveness stemmed from a fundamental change in attack geometry. Traditional depth charge attacks required the escort vessel to pass directly over the submarine's position. This meant losing sonar contact during the critical final approach. The submarine, tracking the destroyer's propeller sounds through its own hydrophones, could time evasive maneuvers to coincide with the moment the destroyer lost contact. Sharp course changes, rapid depth variations, anything to move away from the predicted point where depth charges would detonate. German submarine commanders became expert at this dance. Lieutenant Erich Topp, commanding U-552, survived multiple depth charge attacks through November 1942 using precisely calculated evasive maneuvers. His technique was taught at submarine school. Wait for the destroyer to lose contact, count to 15, execute hard turn to starboard, increase depth by 50 meters, level off, listen for explosions. The depth charges would detonate where U-552 had been, not where it was. The technique saved countless submarines. Hedgehog eliminated this advantage entirely. The escort vessel maintained continuous sonar contact throughout the attack. Bombs were fired while the submarine was still, clearly tracked, still visible on sonar, still within detection range. They landed 250 yards ahead of the attacking ship, directly in the submarine's path. The elliptical pattern covered an area large enough that minor position errors didn't matter. The submarine had no warning the attack had begun, no sound of depth charges rolling off the stern, no turbulence to exploit. Just sudden, catastrophic impacts from bombs the crew never heard approaching. The psychological impact was profound. Oberleutnant Friedrich Steinhoff, serving aboard U-230, described the transformation in a letter written after his capture in May 1943. We believed we understood the rules of underwater combat. Dive deep when detected. Evade during the blind period. Surface after dark. These rules had kept us alive through 8 war patrols. Then we encountered a destroyer that maintained contact while firing weapons we couldn't detect. 3 bombs hit our boat before we could react. 20 men died instantly. The rest of us abandoned ship as she sank. In that moment, I understood our training had become obsolete. The ocean no longer protected us. Steinhoff's realization was spreading through the U-boat force by mid-1943. The statistics were becoming impossible to ignore. In May 1943 alone, 41 German submarines were lost. Admiral Dönitz, commanding the U-boat arm, withdrew his boats from the North Atlantic convoy routes temporarily. The period became known as Black May in German naval records. The withdrawal was unprecedented. For the first time since 1939, German submarine operations in the Atlantic were suspended due to unsustainable losses. The causes were multiple. Improved Allied radar allowed aircraft to detect surfaced submarines at night. Long-range patrol aircraft closed the mid-Atlantic air gap where submarines had previously operated safely. Escort carriers provided continuous air cover for convoys. Breaking of German naval codes allowed convoy routing around submarine concentrations, and Hedgehog gave surface escorts a weapon that could kill submarines reliably while maintaining sonar contact. The combination was devastating. German submariners found themselves hunted continuously, attacked from air and surface, unable to hide even when submerged. The underwater sanctuary they had relied upon was being stripped away by technology they couldn't counter. The engineering that made Hedgehog so effective was deceptively simple. Each bomb was essentially a streamlined projectile 7.2 inches in diameter with a hollow steel tail. The tail fit over the launcher's spigot. Cordite propellant charges, stored in the launcher cradle, fired when electrically triggered. The explosion drove against the spigot, launching the bomb at approximately 45 degrees elevation. The bombs reached altitude, then fell in a ballistic arc. They entered the water nose first at terminal velocity, approximately 23 feet per second sink rate. A submarine at 200 feet depth would be reached in under 9 seconds. At 750 feet, the submarine's maximum test depth, bombs arrived in 30 seconds. Compare this to Mark 6 and Mark 7 depth charges, which sank at 8 and 9 feet per second, respectively. Even the improved Mark 9 depth charge, introduced late in the war, only achieved 14.5 feet per second. Hedgehog bombs reached their target in half the time of older weapons and 50% faster than improved depth charges. This rapid sink rate gave submarines less time to execute evasive maneuvers. From the moment bombs entered the water until impact, perhaps 10 seconds elapsed. In that brief window, a submarine could barely begin a turn, let alone execute the complex evasion patterns that had worked against depth charges. The contact fuse design was crucial. As each bomb fell through water, a small propeller on the nose began spinning. This armed the fuse after the bomb had traveled a safe distance from the launching ship. Upon striking any hard surface, whether submarine hull or ocean floor, the fuse triggered detonation. The explosive charge, 35 pounds of torpex, generated approximately 46,000 foot-pounds of energy in direct contact with the target. For comparison, a standard depth charge contained 300 pounds of torpex but detonated from distance. The energy reaching the submarine was dispersed, weakened by water absorption. Hedgehog's contact detonation delivered concentrated force directly to the hull. Naval architects calculated that a single Hedgehog hit would breach a submarine's pressure hull in most cases. 2 hits guaranteed catastrophic flooding. 3 or more hits meant instantaneous destruction. Post-war analysis of recovered submarine wrecks confirmed these calculations. U-175, sunk by USS Spencer in April 1943, showed 3 distinct penetrations consistent with Hedgehog strikes. The holes, each approximately 4 inches in diameter, had been punched cleanly through 30mm steel plating. Water pressure at the submarine's final depth of 280 feet had enlarged the breaches through progressive tearing of the weakened metal. Final hole diameters measured approximately 8 inches. Through these breaches, the Atlantic Ocean had poured into U-175 at an estimated 1,200 gallons per minute. The submarine sank in less than 90 seconds from first impact to final plunge. 41 men died. Only 13 survived, blown clear of the boat by the force of internal air pressure escaping through the breaches. Their testimony provided Allied interrogators with detailed accounts of what Hedgehog attacks felt like from inside a submarine. The accounts were remarkably consistent. No warning. The first indication of attack was the sound of impact striking the pressure hull. Survivors described it as metallic thuds, like sledgehammers hitting the outside of an oil drum. Then immediate chaos, water erupting through breaches, Lights failing as electrical systems shorted, men thrown against bulkheads as the boat lost trim. Emergency lighting revealing waterfalls cascading through ruptured hull plates. Temperature rising instantly as water compressed the trapped air. The mad scramble for escape hatches. Most never made it. By mid-1943, German submarine commanders understood they faced a weapon that had fundamentally altered the tactical balance of underwater warfare. Training doctrine at submarine school began emphasizing new procedures. Avoid prolonged submerged operations in areas with heavy Allied presence. If detected by surface escorts, attempt to escape at high submerged speed rather than diving deep. If escape impossible, surface immediately and engage with deck guns rather than remaining submerged. The desperation of these new doctrines revealed how thoroughly Hedgehog and related technologies had undermined German confidence. Surface and fight suggested that remaining underwater, once considered the ultimate protection, had become a death sentence. Oberleutnant Reinhard Suren, one of Germany's most successful submarine commanders, wrote in his patrol report from July 1943 that the ocean no longer provided sanctuary. "We are hunted continuously. Allied escorts maintain contact regardless of our depth or evasive maneuvers. Their forward-throwing weapons strike before we can react. I have lost confidence in our ability to survive sustained operations in the North Atlantic. 3 of my most experienced officers share this assessment. We operate now not with expectation of success, but with knowledge that each patrol may be our last." Suren survived the war, but his assessment proved prophetic for most of his comrades. Between May 1943 and May 1945, German submarine losses accelerated, catastrophically. Of 783 U-boats lost during the entire war, over 600 were destroyed after May 1943. The casualty rate among submarine crews reached 75%, making it proportionally the most dangerous service in any nation's military. 30,000 German submariners died at sea, most drowned in crushed steel hulls at the bottom of the Atlantic, killed by weapons they couldn't see, couldn't hear approaching, and couldn't evade. The psychological impact of Hedgehog extended beyond individual crews. It affected German naval planning at the highest levels. Admiral Dönitz, promoted to Commander-in-Chief of the entire German Navy in January 1943, recognized that conventional submarine operations had become suicidal. He ordered accelerated development of advanced submarine types. The Type 21, called the Elektroboot, featured streamlined hulls, massive battery capacity for sustained high-speed submerged operation, and schnorkel systems, allowing diesel operation while submerged. These submarines could theoretically evade Allied detection through superior underwater performance, but they arrived too late and in insufficient numbers. Only one Type 21 boat completed a war patrol before German surrender in May 1945. Meanwhile, Allied production of Hedgehog-equipped escorts accelerated. The United States Navy adopted the weapon in late 1942 through reverse Lend-Lease. American destroyer escorts, purpose-built for anti-submarine warfare, received Hedgehog as standard equipment. These ships, smaller than fleet destroyers but optimized for convoy protection, proved devastatingly effective submarine hunters. USS Eugene E. Elmore, a Buckley-class destroyer escort, demonstrated the weapon's lethal efficiency during an engagement on May 29, 1944. The ship was part of Task Group 21.11, escorting the carrier USS Block Island off the coast of West Africa. At 2100 hours, Block Island was torpedoed by U-549, commanded by Kapitänleutnant Detlev Krankenhagen. The carrier began sinking immediately. While sister ships USS Ahrens and USS Payne moved to rescue survivors, Elmore pursued the attacking submarine. Krankenhagen was an experienced commander. He understood Allied anti-submarine tactics. After firing the torpedo that struck Block Island, he took U-549 deep and turned to port, executing a course reversal timed to exploit the sonar disruption that normally occurred during depth charge attacks. He had used this technique successfully on previous patrols. This time, his expertise proved worthless. Elmore's sonar operator maintained continuous contact throughout U-549's maneuver. At 21:02 hours, with the submarine attempting to slip beneath the destroyer at test depth, Elmore fired its first Hedgehog pattern. 24 bombs arced ahead of the ship, entering the water in their characteristic elliptical pattern. Krankenhagen heard them coming through his hydrophones. The sound was distinct from depth charges, not the heavy splashes of barrels rolling off astern. Instead, multiple lighter impacts spread across a wide area directly ahead of his boat. He ordered emergency dive to maximum depth. Too late. The bombs were already sinking, falling at 23 feet per second through the dark Atlantic water. The first pattern missed. Elmore's sonar showed U-549 still intact, still moving, attempting to increase depth. The destroyer maintained contact, turned, reloaded the Hedgehog launcher. The reload process took 3 minutes. During those 3 minutes, Krankenhagen made every evasive maneuver in his tactical repertoire. He varied depth, changed course, reduced speed to minimize noise signature. Elmore's sonar tracked every movement. At 21:08 hours, the destroyer made its second attack run. Another 24 bombs fired ahead, landing in a perfect pattern centered on U-549's projected position. 30 seconds after the bombs entered the water, Elmore's sonar operator heard 3 distinct underwater explosions. 3 Hedgehog bombs had struck U-549 directly. The first bomb punched through the pressure hull near the forward torpedo room. Water erupted inward at 400 gallons per minute. The second bomb struck amidships, breaching the control room area. The third hit aft, near the engine room. Internal pressure began rising immediately as flooding water compressed the air inside the hull. Temperature soared. Men in the forward compartments drowned within seconds as seawater filled their spaces faster than they could react. Those in the control room had perhaps a minute to comprehend their fate before the pressure hull failed completely. 4 minutes after the explosions, Elmore's sonar detected a heavy crunching sound. U-549's pressure hull had imploded at crush depth. The sound was distinctive, unmistakable. Naval architects called it structural collapse. Submariners called it the sound of death. 56 men died instantly. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Elmore's commanding officer, not entirely certain U-549 was destroyed, made 2 additional Hedgehog attacks on the submarine's last known position. Both patterns landed silently, no explosions. Confirmation that the submarine was gone. The destroyer slowly circled the area for 20 minutes, sweeping with sonar, seeking any trace of the U-boat. Nothing. Only an expanding oil slick on the surface, marked by debris and fragments of the submarine's wooden decking. The engagement from initial torpedo attack to U-549's destruction had lasted 48 minutes. In that time, Elmore had demonstrated every advantage Hedgehog provided: continuous sonar contact throughout the attack, rapid reload and re-attack capability, silent misses that allowed immediate follow-up, and devastating lethality on direct hits. The pattern was repeated across the Atlantic throughout 1943 and 1944. USS Buckley engaged U-66 inches, May 1944, in a remarkable surface action that included ramming, but earlier Hedgehog attacks by other escorts had already damaged the submarine. USS England, a destroyer escort operating in the Pacific, achieved an unprecedented record in May 1944 by sinking 6 Japanese submarines in 12 days, most using Hedgehog attacks. The weapon's versatility became apparent. While developed primarily for the Atlantic campaign against German U-boats, it proved equally effective against Japanese submarines in the Pacific. The fundamental physics of underwater combat applied universally. Contact detonation against pressure hulls was lethal, regardless of submarine nationality or design. For German submariners still on patrol by late 1943, the psychological burden became unbearable. They understood the mathematics of their situation. Every patrol, the probability of death increased. Every encounter with Allied escorts meant facing weapons that had been specifically designed to counter every defensive tactic they knew. Korvettenkapitän Peter Kremer, commanding U-333, wrote in his memoir decades after the war about the transformation in submarine morale during this period. "We entered the war as hunters. We believed in our superiority, our invisibility beneath the waves. By 1943, we had become prey. The Allies possessed technology that stripped away our advantages. Their forward-throwing weapons could strike us while we remained under sonar observation. There was no escape, no evasion that worked consistently. We continued operating because duty demanded it, but we harbored no illusions about survival. Every man aboard understood that each dive might be our last. The boats that returned to port after Successful patrols were regarded with mixture of awe and disbelief. How had they survived? What luck or tactical brilliance had allowed them to evade the hunters? Often, the answer was neither luck nor brilliance, but simply that they had avoided detection entirely. Submarines that encountered Allied escorts equipped with modern sonar and Hedgehog rarely survived. The statistics were unambiguous. Between July 1943 and May 1945, 53 confirmed U-boat kills were attributed to Hedgehog attacks. This represented only a fraction of total submarine losses during that period, but the weapon's impact extended far beyond its direct kill count. Hedgehog forced fundamental changes in German submarine tactics and doctrine. It eliminated the deep-diving sanctuary that had been central to submarine defensive strategy. It made prolonged submerged operations in convoy areas suicidal. It pushed submarines away from the North Atlantic convoy routes, where they had once operated with devastating effectiveness. The broader impact on the Battle of the Atlantic was decisive. British imports of food and war materials, which had fallen to dangerously low levels by March 1943, recovered dramatically during the second half of that year. The massive buildup of American forces in Britain for the Normandy invasion proceeded without significant submarine interference. Over 2 million American troops crossed the Atlantic between mid-1943 and June 1944 with minimal losses to submarine attack. The transatlantic supply line became secure. Winston Churchill's greatest fear, that Britain might be strangled by submarine blockade before American industrial power could be brought to bear, had been overcome. Technology, tactics, and industrial production had combined to defeat the U-boat threat. Hedgehog represented one element of this combination, but an important element. It provided Allied escorts with a weapon that could kill submarines reliably while maintaining the sonar contact necessary for accurate attacks. The weapon's introduction in 1942 coincided with other Allied advantages. Breaking of German naval Enigma codes allowed convoy routing to avoid submarine concentrations. Long-range patrol aircraft closed the mid-Atlantic air gap. Escort carriers provided continuous air cover. Hunter-killer groups could pursue submarines aggressively rather than remaining tied to convoy defense. Short-range communication systems allowed coordinated attacks by multiple escorts. The combination was overwhelming. German submarines, which had nearly won the Battle of the Atlantic in early 1943, found themselves systematically hunted to extinction by mid-1944. The casualty statistics tell the story with brutal clarity. During the entire war, Germany commissioned 1,162 submarines. Of these, 785 were sunk by enemy action, 156 surrendered at war's end. The remainder were scuttled or destroyed by other means. 30,000 German submariners died at sea, 75% casualty rate. No other military service in any nation suffered proportionally higher losses. For comparison, the German army sustained approximately 30% casualties, the Luftwaffe approximately 40%. Japanese kamikaze pilots, who flew suicide missions, had lower casualty rates than German submarine crews. The men who served in U-boats knew these statistics. They watched boats depart on patrol and never return. They saw crews grow younger as experienced submariners died and were replaced by teenagers with minimal training. They understood their chances of survival decreased with every passing month. Yet they continued operating because duty, discipline, and belief in their cause compelled them forward. The belief system that sustained German submariners through 1944 and 1945 deserves examination. How did men continue serving in a force that had clearly lost tactical and technological superiority? What motivated them to board submarines, knowing that 3 out of 4 would never return? The answers were complex and varied among individuals. Some believed in National Socialist ideology and fought for political reasons. Others served from professional naval tradition, refusing to abandon their posts regardless of odds. Many simply had no choice. Refusing to board a submarine meant court-martial and execution. Desertion was punishable by death, and families of deserters faced persecution. So they served. They boarded their boats, submerged into the Atlantic, and faced Allied hunters equipped with technology they couldn't counter. Among the weapons they feared, Hedgehog held special psychological significance. Depth charges, however deadly, were familiar. Submariners understood depth charge tactics. They knew the sounds, the patterns, the evasion techniques. Depth charges exploded whether they hit or missed. creating noise and turbulence that could be psychologically reassuring even during an attack. At least you knew the attack was happening. You could track the explosions, estimate distance, gauge whether the pattern was moving closer or farther away. Hedgehog attacks offered no such comfort. The first indication of attack was often direct impact. No warning splashes, no preliminary explosions to track. Just sudden catastrophic hits from bombs the crew never heard approaching. If the pattern missed, complete silence. The submarine remained under sonar observation, waiting for the next attack, knowing it could come at any moment without warning. Survivors of Hedgehog attacks, when interrogated after capture, consistently described the weapon as particularly terrifying, precisely because of its silence and precision. Oberleutnant Klaus Bargston, captured when U-521 was forced to surface after Hedgehog damage in June 1943, told British interrogators that the psychological impact of the weapon exceeded its physical destructiveness. "We could survive near misses from depth charges through good fortune and strong construction, but your forward-throwing bombs struck with precision we couldn't evade. There was no blind period to exploit, no turbulence to hide in, no warning of attack. We simply waited in our boat, knowing that at any moment bombs might strike without announcement. The psychological burden was intolerable. Better to die quickly than endure that fear for hours." Bargston's testimony was classified at the time, but released decades after the war. His assessment reflected broader patterns in German submarine morale during the final 2 years of conflict. Medical records from submarine crews returning to port showed increasing rates of psychological breakdown. Combat fatigue, as it was termed, affected both experienced crews and new recruits. The constant stress of being hunted, the knowledge that defensive tactics no longer worked, the understanding that survival depended more on luck than skill, all combined to break men psychologically even before physical destruction of their submarines. The Kriegsmarine attempted various countermeasures to Allied anti-submarine technology. Development of acoustic torpedoes, the Falke and later the Zornkönig, allowed submarines to attack escorts without surfacing to periscope depth. These homing torpedoes theoretically gave U-boats a weapon against the destroyers hunting them. Allied countermeasures, particularly the Foxer acoustic decoy towed behind escorts, largely neutralized this advantage. Development of radar warning receivers, the WWII device, helped submarines detect approaching aircraft, but Allied radar evolved to frequencies the WWII couldn't detect. Introduction of schnorkel systems allowed diesel operation while submerged, reducing the need to surface for battery charging. But schnorkel operation was slow, noisy, and often malfunctioned in rough seas. The Type 21 submarine, with its revolutionary design and performance characteristics, promised to restore German underwater superiority, but it arrived too late. Only 2 Type 21 boats completed war patrols before German surrender. Against every German countermeasure, Allied technology and tactics evolved faster. The industrial capacity of Britain and America allowed rapid development, testing, and deployment of new systems. German industry, strained by strategic bombing and resource shortages, couldn't match this pace. By 1944, the technological gap had become insurmountable. The human cost of this technological defeat remains difficult to comprehend fully. 30,000 men drowned in steel coffins at the bottom of the Atlantic, Pacific, and Mediterranean. Each death was individual, personal, terrifying. No 2 submarines sank exactly the same way. Some imploded instantly at crush depth, killing all aboard before they could comprehend their fate. Others flooded gradually, giving crews minutes to understand they were dying. Some surfaced damaged, allowing partial crew evacuation before the final plunge. Others trapped entire crews in airtight compartments, where men died slowly from oxygen depletion or carbon dioxide poisoning. The physical details of submarine deaths are documented in salvage reports and survivor testimony. Pressure hulls breached by Hedgehog bombs showed characteristic penetration patterns, entry holes approximately 4 inches in diameter, enlarged by water pressure to 8 or 10 inches. Internal damage from the explosive force itself was often limited to the immediate impact area. The real killer was flooding. At depths of 200 to 300 feet, water pressure forced ocean into the submarine faster than pumps could expel it. Compartments flooded in seconds. Watertight doors, designed to contain flooding, often couldn't be closed in time. Even when successfully closed, they only delayed the inevitable. Water found its way through hull penetrations, ventilation systems, piping runs. The submarine grew progressively heavier, losing buoyancy, settling deeper. Increased depth meant increased pressure, which accelerated flooding. The cycle was unstoppable once initiated by a successful Hedgehog hit. Survivors who escaped from submarines struck by Hedgehog described the interior chaos during the final minutes. Emergency lighting failing as electrical systems shorted, men scrambling toward escape hatches that couldn't be opened until the submarine reached shallower depth. The terrible sound of water roaring through breaches, rising temperature as air compressed. The knowledge that death was coming and nothing could prevent it. Some men chose to remain at their posts, continuing to operate equipment until water reached them. Others made for escape routes that proved blocked or impossible to reach. A few, blown clear of the submarine by air pressure escaping through breaches, survived to be rescued. Most didn't. Post-war analysis of recovered U-boat wrecks provided physical evidence of Hedgehog effectiveness. U-869, discovered off the New Jersey coast in 1991, showed damage consistent with Hedgehog attack. 2 penetrations in the pressure hull, each approximately 4 inches in diameter, with outward splayed edges indicating internal explosive force, followed by pressure collapse. The submarine had sunk in 240 feet of water, well within Hedgehog's effective range. Forensic examination of the wreck suggested the crew had no warning of attack. Equipment was secured for normal submerged operations. No evidence of emergency procedures having been initiated before the fatal strikes. U-853, sunk by USS Moberly and USS Atherton off Rhode Island in May 1945, showed similar damage patterns. Multiple Hedgehog impacts had breached the pressure hull in several locations. The submarine had been hunted for several hours before the fatal attack. Sonar tracking showed the boat attempting various evasive maneuvers, all unsuccessful. The final Hedgehog pattern struck, while U-853 was attempting to rest on the sea bottom at 100 feet depth. Even this desperate tactic, lying silent and motionless on the ocean floor, failed to prevent detection and destruction. The legacy of Hedgehog extends beyond its immediate impact on World War II submarine warfare. The weapon established principles that remain relevant in modern anti-submarine operations. Forward-throwing weapons that maintain sonar contact during attack. Contact fuses that eliminate wasted ordnance on misses. Patterns that cover areas large enough to account for position uncertainty. These principles informed development of post-war anti-submarine systems. The British squid mortar, introduced in late 1943, expanded on Hedgehog's design by firing 3 larger depth bombs that detonated at preset depths. The limbo system, developed after the war, used 3 gyro-stabilized barrels firing 350-pound projectiles to 1,000 yards range. American development led to the Weapon Alpha system, then eventually to ASROC, the anti-submarine rocket, which could deliver nuclear depth bombs or homing torpedoes to ranges exceeding 10 miles. Soviet development, after examining captured Hedgehog launchers, led to the MBU 200 inches 1949 and the improved MBU 600 inches 1956. These weapons derived from the Hedgehog have been largely phased out in Western navies in favor of homing torpedoes and rocket-launched weapons. But the fundamental concept, attacking submarines while maintaining sensor contact, remains central to anti-submarine warfare doctrine worldwide. Modern anti-submarine helicopters, ships, and aircraft all employ weapons that can be delivered while the submarine remains under surveillance by active or passive sonar. The lesson, learned in the Atlantic between 1942 and 1945, endures. Continuous contact with the target is essential for successful submarine prosecution. For the German submariners who experienced Hedgehog attacks and survived, the post-war years brought opportunity for reflection on their wartime experiences. Many wrote memoirs detailing their service. Peter Kramer published U-Boat Commander in 1984. Herbert Werner wrote Iron Coffins in 1969. These accounts, written decades after the events, revealed the lasting psychological impact of serving in the U-boat force during its period of technological obsolescence. Werner, reflecting on his experiences as a young officer aboard several submarines including U-557, wrote about the transformation in submarine warfare that occurred during 1943. We had been taught that diving deep meant safety. The ocean depths would protect us from surface ships. This belief sustained us through early war patrols when depth charges were the primary threat. But the introduction of forward-throwing weapons shattered this certainty. We learned that no depth provided sanctuary from a weapon that could strike while we remained under sonar observation. The psychological shift was profound. We went from hunters confident in our invisibility to prey that understood we could be tracked, targeted, and killed regardless of our tactical skill. Werner survived the war and eventually emigrated to the United States, where he lived until his death in 2013. His memoir remains one of the most detailed accounts of submarine warfare from the German perspective. His descriptions of Hedgehog attacks, based on multiple encounters and conversations with other survivors, emphasize the weapon's psychological impact as much as its physical destructiveness. Kremer, who commanded U-333 through multiple patrols, described similar experiences. His submarine survived several Hedgehog attacks through combination of luck, skilled seamanship, and the weapon's inherent limitations. Hedgehog, while deadly, was not infallible. Patterns could miss if the target submarine executed violent, evasive maneuvers at the moment of attack. Contact fuses occasionally failed to detonate. Rough seas disrupted launcher operations. But these limitations didn't change the fundamental reality that submarines under Hedgehog attack faced odds far worse than with conventional depth charges. Kremer's memoir acknowledged that German submarine forces had been defeated as much by technology as by tactics or industrial production. The Allied anti-submarine campaign succeeded because it combined multiple technological advantages: superior industrial capacity, code-breaking intelligence, and aggressive tactical doctrine. Hedgehog represented one element of this combination, but it was an important element because it addressed a fundamental weakness in anti-submarine operations: the loss of sensor contact during attack. The German submarine service never fully recovered from the defeats of May 1943. Despite reorganization, new tactics, advanced submarines, and desperate determination, U-boats never regained the operational effectiveness they had achieved during the first happy time of 1940 through 1941. The technological and tactical balance had shifted irreversibly in favor of the Allies. Admiral Dönitz, who became Commander-in-Chief of the German Navy in January 1943 and ultimately briefly served as President of Germany after Hitler's suicide, spent the final weeks of war attempting to evacuate German troops and civilians from the Eastern Front ahead of advancing Soviet forces. Submarine operations in the Atlantic had become secondary to this mission. When Germany surrendered in May 1945, 156 U-boats surrendered to Allied forces. Under the terms of Operation Deadliest, most were towed to deep water northwest of Ireland and scuttled. A few were retained for technical evaluation. U-2513 and U-3008, both Type 21 submarines, were taken to the United States for testing. Their advanced design influenced American submarine development for years afterward, but their capabilities came too late to affect the war's outcome. The final accounting of the Battle of the Atlantic reveals the scale of the struggle. German submarines sank approximately 3,000 Allied merchant ships, totaling over 14 million tons. They sank 175 Allied warships. They killed over 72,000 Allied seamen and unknown thousands of passengers on torpedoed ships. Against this, Germany lost 785 submarines and 30,000 submariners. The exchange rate, measured in tonnage sunk versus submarines lost, favored Germany in the early war years, but reversed dramatically after May 1943. Technology, tactics, and industrial capacity combined to defeat the submarine threat. For the men who served in U-boats and survived, the post-war years often brought difficult adjustments. They had served in a force that had been systematically defeated despite enormous courage and sacrifice. They had witnessed technology render their training and tactics obsolete. They had seen thousands of comrades die in circumstances that left no hope of survival. Some, like Werner and Kremer, wrote about their experiences, attempting to explain to later generations what submarine warfare had been like from inside the steel hulls. Others remained silent, preferring to leave their wartime memories private. A few settled in Allied nations, including the countries whose forces had hunted them. In 1985, a small gathering of German submarine veterans occurred in the United States. Several former U-boat officers, including men who had survived Hedgehog attacks, met informally to discuss their shared experiences. Horst Bredow, a former radio operator who had served on multiple boats, spoke about the technological transformation that had defeated German submarines. "We believed our invisibility beneath the waves made us invincible. Allied technology proved us wrong. Your sonar tracked us continuously. Your forward-throwing weapons struck us while we remained under observation. Your industrial capacity produced escorts, aircraft, and weapons faster than we could destroy them. We were defeated not by cowardice or incompetence, but by facing an enemy with superior technology and unlimited resources. Those of us who survived did so mostly through luck. The acknowledgement was significant. German military tradition emphasized courage, duty, and tactical skill. Admitting technological and industrial inferiority was difficult for men raised in that tradition, but the statistical evidence was overwhelming. German submarine forces had been destroyed by enemy technology and production capacity that they simply couldn't match. The lesson resonated beyond military circles. Post-war German industrial development emphasized technological excellence and efficiency. Companies like Mercedes-Benz, BMW, and Porsche built their reputations on engineering quality that could compete globally. The emphasis on technological competitiveness in civilian industry partly reflected lessons learned during the war about the consequences of falling behind in technological competition. The story of German submarines encountering Hedgehog mortars is ultimately a story about technological transformation in warfare. Superior technology deployed with adequate industrial capacity and sound tactical doctrine proved decisive. German submariners were not inferior sailors. They were not lacking in courage or determination. They were operating obsolescent equipment against enemies possessing superior technology. The 24 bombs fired in circular patterns ahead of Allied escorts represented more than just a weapon system. They represented the culmination of scientific research, engineering development, industrial production, and tactical innovation that together transformed anti-submarine warfare. The sound of those bombs striking submarine hulls became the audio signature of German submarine obsolescence. For the 30,000 men who died in U-boats, most killed after May 1943, technology arrived as an enemy they couldn't see, couldn't fight, and couldn't escape. They drowned in steel coffins at the bottom of the ocean, victims of weapons specifically designed to counter every defensive tactic they had been taught. Their deaths secured Allied victory in the Battle of the Atlantic and ensured that Britain remained supplied and capable of continuing the war. The broader strategic impact was decisive. Germany's attempt to strangle Britain through submarine blockade failed. The Atlantic supply line remained open. American industrial power flowed to Britain without effective interference. 2 million American troops crossed the Atlantic for the Normandy invasion. The massive quantities of equipment, ammunition, food, and fuel necessary for Allied operations in Europe arrived safely. Winston Churchill's greatest fear, that submarine warfare might force Britain out of the war before American power could be fully engaged, never materialized. Technology had defeated the submarine threat. In the final analysis, Hedgehog mortars throwing 24 bombs in circular patterns represented one element of Allied anti-submarine superiority. But it was an important element. It gave surface escorts a weapon that could kill submarines reliably while maintaining the sensor contact necessary for accurate prosecution. It eliminated the blind period that German submarines had exploited throughout the early war years. It forced German submarine doctrine to adapt in ways that reduced operational effectiveness. And it contributed to the psychological defeat of the U-boat force by demonstrating that no depth provided sanctuary from Allied technology. The legacy endures in modern naval warfare. Forward-throwing weapons, continuous sensor contact during attack, and contact-fused projectiles remain standard in anti-submarine operations. The principles established in the Atlantic between 1942 and 1945 continue influencing naval doctrine worldwide. The German submariners who first experienced Hedgehog attacks paid with their lives to teach lessons that transcend their defeat. Technology transforms warfare faster than training, doctrine, or courage can adapt. Industrial capacity matters more than individual skill in prolonged conflict. Scientific innovation backed by adequate resources determines outcomes in modern war. These lessons, bought with 30,000 submarine graves at the bottom of the Atlantic, remain relevant in contemporary military competition. The iron coffins that litter the ocean floor hold stories of men who learned too late that their protective sanctuary had been stripped away by science. Their tale stands as testament to how rapidly technological advantage can shift in warfare, and to the decisive impact of engineering excellence combined with industrial capacity. For the men who heard the metallic impacts of Hedgehog bombs striking their submarine hulls, Those sounds marked their transition from invisible predator to exposed prey. From confident warrior to terrified victim of technology, they could not escape. The ocean depths that had once protected them became their graveyard, penetrated by weapons that reached through water itself to deliver death with mechanical precision. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now and don't forget to subscribe.